the old saying, a chain is only as strong as its weakest link. But sometimes we become complacent to this reality in our own work environment. Unfortunately, when an accident occurs as a result of defective lifting equipment, it is very often an innocent bystander who is injured, or worse, killed. In this program, we will look at a range of lifting equipment and what fundamental principles should be followed to prevent accidents. There are many different types of lifting equipment and accessories available. The equipment used will vary according to the work environment and the types of tasks to be performed. Examples of lifting equipment commonly used in industry are chain slings of various grades and types, such as single leg and 2, 3, and 4 leg assemblies. Other slings, consisting of a large variety, including galvanized, endless, fiber core, wire strand core, synthetic web, and round slings. Accessories, such as plate clamps, drum lifters, eye bolts, shackles, and the list goes on. Regardless of the type of lifting equipment you have in your workplace, there are 4 things you must do to ensure their continuing safe application. 1. Pre-use checks. You must conduct pre-use checks on all lifting equipment prior to any lifting operation. 2. Care of equipment. You must take care of your equipment when it is being used. 3. Perform planned periodic inspections. Conduct regular inspections which critically examine all lifting equipment. And 4. Correct storage of equipment. You must store all equipment appropriately to avoid damage. Let's look at each of these in a little more detail. Understanding why and what pre-use checks need to be done will not only ensure a safer working environment, but will explain why defects occur and will help to prevent their occurrence. Let's start by looking at chain slings. Stretching and elongation of the links occurs as a result of overloading the chain sling, or more specifically using the chain sling to lift a load which is in excess of the chain's safe working load. Chain slings are tested to ensure they are capable of withstanding the forces of the safe working load. In most cases, testing practices require that a proof load of twice the safe working load be applied. Here we see a chain sample which is being tested to destruction. Digital indicators at this point show forces of twice the safe working load being applied, and the chain is showing no signs of stress. At 3 times the safe working load, we can actually see the chain stretching through elongation of the links, and it is not until 4 times the safe working load that the chain breaks. Although this may seem like a good buffer or comfortable safety margin, it must be remembered that if a chain sling is taken above its safe working load, the undue stress may weaken certain links, resulting in an accident waiting to happen. To check a chain sling for stretch, twist one link to expose the inner link end. If you have difficulty twisting the links or find they are tight to move, then the chain sling should be taken out of service and tagged with a suitable danger tag stating that the chain is stretched and should not be used under any circumstances. It should then be sent to an approved testing center. If a chain sling is clearly badly stretched, it should be cut up or destroyed as soon as possible. Bent or deformed links usually occur as a result of improper use. There are 5 major causes. 1. Incorrect slinging practices while lifting. A good example is shown here where the chain sling is wrapped around sharp corners. You should always use pads or bent links will result. 2. Improper lowering of a load. This usually occurs through dropping or lowering a load onto the chains instead of putting in chocks to support the load, which allows the chain sling to be removed freely and without damage. 3. Exposure to excessive heat. This can occur when welding equipment is used on objects supported by a chain sling. 4. Knots. It is bad practice to tie a knot in any chain. If a chain sling needs to be shortened, an appropriate chain shortener should be used. 5. Twists and kinks. These will cause undue stress on the chain. A kink that pulls free during a lift will cause jolting or shock loading on the chain. Bent and deformed links are easy to detect on a free hanging chain, so always check that the chain sling is perfectly straight before removing it from the storage rack. These also occur from improper use and neglect of the chain sling. The major contributing factors are lowering and/or dropping the load onto the chain and hitting the chain against objects while load handling. Cuts, dents, and gouges on chains must be assessed as to their likely effect on the safe working load of the chain sling. Speak to the chain sling manufacturer as to whether a cut or gouge should be filed out. Here in this example, we can see clearly that the cut would reduce the chain sling's lifting capacity. In this second example, however, the dent is only small and should not affect the safe working load. In any event, you should get the chain checked by a licensed crane driver or dogman, or if it is particularly bad, send it to an approved tester and have it recertified. Any link which shows evidence of a crack should be taken out of service immediately. A crack suggests that the link has broken down. Once again, replace the link or send it off to an approved tester. Chain slings are designed to permit wear in two areas, the inner link and the outer link. Inner link wear occurs as a natural part of using the sling and is created at the point of contact where each link moves. If the wear is obvious, check with calipers and compare with the manufacturer's allowable wear margins. Outer link wear occurs from activities such as dragging chains from underneath loads and dragging chains to work sites. When excessive outer link wear has resulted, the chain sling should be taken out of service. As a general rule, 10% or above is considered to be excessive, but always check the manufacturer's guidelines. Corrosion to chains may take many forms. However, commonly it will be rust or corrosion caused by exposure to chemicals, particularly acids and alkalis. Any lifting equipment which has signs of excessive corrosion should be taken out of service and destroyed. As we said before, a chain sling is only as strong as its weakest link, so it is important to apply the same pre-use checks to the master links, coupling links, and attachments such as eye bolts, shackles, plate handling devices, chain shorteners, and so on. So, in summary, in the pre-use checks for chain slings, we look for the following: stretching and elongation, bent and deformed links, cuts, dents, and gouges, cracks, excessive wear, corrosion, and finally, damaged master links, coupling links, and attachments. Now, let's move on to look at other common slings. Here we are dealing with essentially two types: wire rope and fiber slings. Before using a wire rope sling, your pre-use check should include the following. A sling with a number of broken wires should not be used. Likewise, when a complete strand is broken, the sling should be taken out of service. Bird caging applies specifically to wire rope slings and indicates that the sling has been forced or twisted in the opposite direction of lay. In some instances, the core of the rope may be exposed or protruding from the strands. Slings in this condition should be returned to the manufacturer for repair or replacement. A good sign of excessive wear is when many single wires are broken. As with chains, excessive corrosion or rust is a sign of weakness, and in these cases the sling should not be used for lifting. Flattened sling eyes are a common sight in many workplaces and are often accepted as normal. Flattened eyes are a sign of damage and they should be replaced. All accessories used with wire slings should be checked for defects and removed from service if found faulty or damaged. Man-made fiber slings are now common throughout the industry. They are used extensively where it has been previously hazardous to use chain and wire slings. Round slings should be checked for damage to the outer sheath, This can be an indication that the load-bearing yarn may also be damaged. If you are unsure whether or not the sling has been in contact with a chemical, it is safer not to use it. Webbed slings should be checked for splitting or webbing pulled apart. Here we see the load-bearing fibers are pulled apart but are still intact. A sling in this condition should not be used. Any damage to the sling webbing, especially cuts, indicates a decreased sling strength. Although the damage can often look minor, it is not always representative of the actual reduction in safe working load. Damage to sling eyes. Cuts, tears, and abrasions in this area are just as critical as with the rest of the sling. Hard spots. These indicate that the sling has been exposed to excessive heat and/or, in some cases, a severe friction burn. As with round fiber slings, a stain could be the remnants of a hazardous chemical. So, in summary, with our pre-use checks we should look for, first, with wire slings, broken wires, bird caging, excessive wear or abrasion, excessive corrosion or rust, damaged sling eyes, and second, with fiber slings, cuts to sheath or webbing, damage to sling eyes, stains, splitting or webbing pulled apart, and finally, hard spots. In order to ensure that slings remain in safe working order while being used, the following basic rules should be adhered to. Select and use the appropriate sling for the job. Check the identification tag for suitability for the task. Never exceed the rated safe working load. Avoid crushing the sling when lowering a load. Never tie a knot in a sling to shorten it. Use the correct sling size or appropriate chain shortener. Do not drag slings on the ground. This causes external wear, and with some slings, grit can penetrate the strands, causing internal wear. Always use pads around sharp edges to protect the sling. Avoid striking the load against any object. Use tails on a load if you suspect it is going to swing around. Do not lift a load suddenly, and avoid shock loading. Ensure the sling is free from kinks. Kinks that pull free can cause shock loading, and kinks will produce weak spots which will reduce the overall safe working load. Ensure the sling is fitted into the hook correctly. A sling not placed on the throat of the hook could slip out. If the hook is fitted with a safety catch, ensure the sling is seated behind it and not interfering with the mechanism. Never use wire slings around sharp-cornered loads. Keep man-made fiber slings away from strong alkalis and acids. Even with constant pre-use checks and care whilst using lifting equipment, there is still a requirement for planned periodic inspections. These inspections provide for critical examination of the equipment and records the results and date of the inspection in an inspection register. Planned periodic inspections cover the same checks as are performed in pre-use checks, but in much greater detail. For example, when checking excessive wear on a chain sling, calipers should be used to obtain an accurate measurement, or when checking a chain for stretch, it should be measured against the chain's effective length. Always ensure you enter all your findings into an inspection register to maintain an accurate performance history of each piece of lifting equipment. In the event that you find a damaged item, such as this hook, you should intensify your inspection because there is likely to be more damage. It is imperative that lifting equipment is stored correctly to ensure that it is properly maintained, to assist in routine inspections, and to prevent damage while not in use. The general rules for storage are: all lifting equipment should be stored off the ground, in a dry place, and protected from the weather. The storage area should be dedicated for storage purposes only, and if it has a concrete floor, it should be painted to prevent rising damp affecting the equipment. All lifting equipment should be logged in a register. Slings should be stored on a suitable frame. Whenever chain slings or wire slings are being stored for prolonged periods, they should be lightly oiled to prevent rusting. Shackles, eye bolts, and other accessories should be stored on a pegboard or shadow board with the safe working load rating labeled below each item. Damaged lifting equipment must be prominently tagged to avoid accidental use. Safety at work is all about identifying, evaluating, and controlling potential hazards. When using any lifting equipment, the steps that have been outlined in this program are vital to ensure a safe working environment.